What's up, guy? If you don't know my name is Anjali, and today I will teach you about one of the four core principles of object-oriented programming in the Java language, which is inheritance. Now, this video will only touch on the topic of inheritance, but I suggest you also study the other three core principles as well as the other basics of object-oriented programming. Before we talk about inheritance, let's discuss for a bit about some elements that come into play inheritance. A class is a generalized form from which objects with differing details can be created. Basically, a class is a blueprint for creating objects. Inheritance, simply put, is the idea of passing down characteristics from a parent class to a child class. You can call the parent class a superclass, while its corresponding child classes are called superclasses. So animal classification is actually a very helpful way to visualize how inheritance in programming works for you. Kingdoms, right? There are kingdoms of animals, then under kingdoms are phylums. Basically, it's used to classify animals and the families that they belong in. Let's not take the whole scope of the animal classification chart. We'll just take a subset of it. So let's have a phylum of vertebrates. So all vertebrates share the same set of characteristics. They all have backbones and they all have the central nervous system. Under vertebrates are another set of groups. They're called classes, where they all share the same characteristics of vertebrates, but each class has their own unique set of characteristics. So let's have a class under vertebrate, which is mammals. Let's not keep mammals alone. They're not alone in the universe. We'll name this class birds. These are two classes that are under vertebrates where they all have backbones and a central nervous system. Difference is that in mammals, they all regulate their body temperature in their environment. They're endothermic animals. Meanwhile, birds have their own set of characteristics like beaks, feathers, claws. Each of them have their own differences, but they are still under vertebrates. Okay, so let's have another set of groups, but this time under the class of mammals. Let's have the order carnivores, and another one under mammals, same, we'll have herbivores. So, carnivores and herbivores, they're still mammals, but carnivores are different from herbivores in that they eat meat, while herbivores eat plants. So this time let's have an example. An example of a carnivore, lion, under carnivores. And then under herbivores, let's have a giraffe. Alright, so a lion is a carnivore, right? Not only that, but a lion is a mammal, and a lion is a vertebrate. So a lion is a carnivore, is a mammal, is a vertebrate. Meanwhile, a giraffe is an herbivore, and is a mammal, and is a vertebrate. Therefore, giraffe is a herbivore, is a mammal, is a vertebrate. Well, you might ask, what about a bird? So what do you want as a bird? Want a parrot? Sure, let's have a parrot. A parrot is a bird, is a vertebrate. So therefore, a parrot is a bird, is a vertebrate. So let's say the vertebrate is a superclass, or a parent class, and then it has characteristics that are passed down to its subclasses or its child classes, I mean mammals and birds. But then the same thing with the child classes under the mammals, carnivores and herbivores. So a lion has all the characteristics of a vertebrate, a mammal, and a carnivore. So in essence, subclasses inherit their characteristics and actions or attributes and methods from their parent classes. Let's see how this is implemented in the practical world of programming. Let's start making a Java project, and we'll call it inheritance, because why not? Okay, so before we begin, let's think of a real-world scenario that we can put ourselves into. Let's say we work for a company that makes robot vacuums, or Roombas. So let's make a Roomba. Or we'll just call it robot vacuum. Okay, so let's just have a very simple robot vacuum. No need to make things complicated. Let's just give it the color black. It's a black robot vacuum. And then let's think of the most essential functions of a robot vacuum. It cleans. So let's just have clean function. Then it's just gonna print out, just for simplicity's sake, just print out the statement clean. Actually, let's make it more interesting. Print out the sound effect it makes when it cleans. Alright, there you go. Interesting vacuum. Alright, so let's have another function. It detects dirt. Dirt detect. Detecting dirt on surface. I'm just making this up as we go along. Then next, we're gonna make it move in 4 directions. Forward, backward, left, and right. Let's make a method for each direction it moves in. Move forward. And it's gonna print out it moving up, yeah. This is gonna take a while, but I think you get the idea. Finally, there we go, we're done. Okay, so these are all the essential functions that the robot vacuum has. So let's move on to the next. We'll make another Roomba. Alright, let's just name this Roomba 1. Then it has all the same functions that the robot vacuum has. Just copy paste that. Okay, so like the generic robot vacuum, it has all the essential features, but it has its own unique feature, which is self-cleaning. It can clean its own waste after it's done cleaning out the floor. You don't have to manually control it. So let's make a method for that. Self-clean. Print out self-clean. There we go. Okay, so we have another Roomba to make. It has the same functions as the generic Roomba, but it has its own unique feature again. Let's make it deep clean. It can deep clean carpets, which are hard to clean with a generic Roomba. Deep clean. Deep clean. Alright, okay, let's have another one. Just final one. Roomba 3. Same thing, but what's its unique feature this time? It can mop. It can mop floors. It can spray water on the floor, then it can mop it. So mop. Spray water and mop. Okay, so here are all the Roombas that we made so far, but then the boss will ask you, hey, let's make one more. Or 5, 10, 50, 100, 1,000. Depends on how successful the company is anyway. And then sooner or later, you'll get tired of copy-pasting all the functions from the original robot vacuum. And what would make things more difficult is that you might accidentally make an error in one of the statements, one of the code, and then you have to check one by one to see if you made some more errors that you might have accidentally made along the way. An advantage of inheritance is that you don't need to copy paste all of the essential functions from the parent class. Okay? What you need to do is to just make the main functions in the parent class, and then in its subclasses, all you have to do is to use the keyword extends. A very important keyword in inheritance. Roomba 1 extends from the parent class, which is robot vacuum. Extends meaning inherits. So the Roomba 1 class inherits the attributes and methods from robot vacuum. Same thing with Roomba 2. Extends from robot vacuum. Then again, one more. And then all I have to do is just erase all the code that you just copy pasted, except for the standout features of each Roomba that you made. So there's this concept in inheritance called specialization, where all of the subclasses have their own special features, and then another one is generalization. The parent class passes down its general characteristics, attributes, and methods down to its subclasses. Robot Vacuum is our superclass. Roomba 1, 2, and 3 its subclasses. Alright, so let's see how this works in the main class now. Name. And then let's make an object of the first Roomba. Okay, so let's put the R1 dot. And what we can see here is that all of the characteristics, attributes, and methods from the robot vacuum class are passed down to the Roomba 1. So the string color, so that's attribute, and then here are all of the methods from robot vacuum. It can clean, it can detect dirt, move backward, forward, plus its own special function, which is self-clean. So let's just try putting it there, and its very own self-clean. Alright, and then let's run. Alright, here we go. So here in the console, you can see all of the methods that are called. It can clean, yeah, whir, detect dirt and surface, move, and then self-clean. So let's try this again, but with the second Roomba. Change the R1 to R2. Before I forget, change the special function from the R2, deep clean. There we go. It's basically the same thing as before in the first Roomba, except for the last function, which is deep clean from the Roomba 2. Try this again in Roomba 3. Change the special function of Roomba 3, which is mop. I think I made it capital. Run. And voila. Spray water and mop. So there you have it. A simplified demonstration of inheritance. I mean, obviously it doesn't look like this in the real world. It's just for you guys to understand how inheritance is applied in coding. The child classes basically inherit all characteristics from its parent class. Meanwhile, each subclass is then specialized through having their own unique characteristics that make them distinct from each other. This helps in having a variety of outputs that are derived from the original object, like the robot vacuum, make all interesting objects that still have the same basic functions but with their own unique twist. It is also useful in code reusability, where you just have to use the extends keyword instead of copy pasting all of the basic functions from a first class and then copy pasting again to another class, making the whole thing seem redundant. Another advantage of inheritance is that you can change the way a method from the parent class works into its subclass. So let's take an example from the robot vacuum class, move forward. So yeah, instead of making this Roomba move forward like a boring Roomba would do, let's make it interesting. Let's make it fly. So instead of moving forward, it can now fly. So let's see if this changes in the main method. Make it all one. Self-clean. It still has the same method name, move forward, except the print statement is now changed. Alright, let's run this. Alright, so you see the difference? Text changes from the move forward method into the console, so it now prints out the statement fly. So this is what we call as method overloading, wherein we change the content of the method from the parent class, but not in the parent class itself. It's still the same, moving forward. Moving forward, moving up. I just realized I made this up the whole time, but hopefully you got the idea. It doesn't matter if it's up. You don't have to change the statements in the parent class. You just have to do it in the subclasses. So there you have it, inheritance in Java. I hope you learned a lot, or at least enough, about how it works. And if you want to dive deeper, you can just research online. So if you somehow like this tutorial, you can go like and comment down below, or not, it's your life. You can also apply inheritance now that you learned some things about it. So hope you have a good day, night, wherever you are. Goodbye.